In this video, we are going to collect the properties of square and square roots by doing these 10 MCQ questions. So let's begin with the first one. So the first question says there is no square number between 50 and 60. So we can verify it. We know that 7 square, which is nearer to 50, which is 49, and the next numbers after 7 is 8, and 8 square is 64. So clearly there is a no square number between 50 and 60. So we'll say that this is a true statement. Now check for the next. So the next question says the difference of two square number is a square number. Well, it may not be, right? What you should know that for difference and sum, the difference of and the sum of two square number may not be square number. Only the product and the quotient of two square number is a square number. So you can verify this also, like say if I take 7 square, which is 49, and let's say if I take 5 square, which is 25, if I find their difference, what you are getting, 9 minus 5 is 4, this is 24, and that's not a square number. So you should note that the difference and sum, right, or sum of two square number may not be a square number. The next question is says that the square of a prime number is a prime. Well, that's not true, and we can verify. Like you may take 5, which is a square, which is a prime number, and its square is how much? 25. You see that it is divisible by 5. Any other number you can take. Let's say if I take 7, which is a prime number, its square is 49. As you know, 49 must be divisible by 7, and therefore we say that this is a false statement. The square of a prime number is never a prime number. It's not maybe, it's never a prime number. The next is the square of an even number contains even number of digits. Even number, like say, if I take 12, 12 is an even number, and if I find it square, 12 square is how much? 144. But you can see that it has odd number of digits. Others number also, like 11 has, no, we have to take what? Even number. Let's say if I take an even number, let's say 8, 8 square is 64, that is even. But when I take other numbers, let's say for example I take any other even number, let's say 14, and 14 square is how much? 196. It has odd number of digits, so we should say that this is a false statement, as the even numbers, the square of an even number can be odd or it can be even, right? It can be odd or it can be even number of digits. Now, this question says that the product of two square numbers is always a square number. Well, this is true. As I said, that the product and quotient of two square number is always a square. It's only the sum and the difference of two square number may not be a square number. So you can verify using any two square number. Let's say if I take 4, 4 square is how much? 16. If I take 3 square, 3 square is 9, and its product is what? We know that 16 multiplied by 9 is how much? 144, which is what? It is a square of 12. So we can say that this is a square of 12. So we'll say that the statement is true. The product and the quotient, as well as the quotient of two square number, is a square number. This question says that no square number is negative. Yeah, that's a correct statement. But you know that even if I take a negative number, let's say minus 3, and if I find the square, it's minus 3 multiplied by minus 3 has to be positive. As you know that when negative numbers are multiplied, right? Negative multiplied by negative is positive. That's why if I take any negative number, its square will always be positive. So whether a number is a negative or positive, square of a number is always positive, and therefore we should say this is a false statement. This is a false statement. So square of a number cannot be negative. This question says the square root of this number, the square root of this number shall contain 3 digits. Well, there is a rule for this. Let's begin with the number of digits when it is even. So for that rule is, it's the number of digit divided by 2, right, should give you the number of digits in the square root. For example, if I say there is a 6-digit number, then the number of digits in square root will be 6 divided by 2, that it should, and it will be a 6 3-digit number. And in case of an odd, as you can see over here, odd, in case of odd number of digits, the rule is the number of digit plus 1 divided by 2 will result to give you the number of digits in the square root. So over here, as you can see, it is a 5-digit number. So if I add 1 to 5 and divide it by 2, 5 plus 1 is 6 divided by 2. So it should end with 3-digit number. And I can see this is what they have written. It's a 3-digit number. So this is a correct statement. Now in this question, it says 4,000 is a square number. So what we know that any square number will end with even number of zeros. Like it can end with 2 zeros, it can end with 4 zeros, it can end with 6 zeros, and so on. It never ends with odd number of zeros, maybe 3 zeros or 5 zeros. So as you can see over here, it is ending with 3 digits, so it cannot be a square number. So this is a false statement. The next question says all numbers ending with even number of zeros are always a perfect square. Well, this is not true. As you know, 200 is ending with 2 zeros, an even number of zeros, but it is not a perfect square. Same way, we can say that although 100, if I talk about, it is ending with even zeros, it is a square. So this is correct. Therefore, but it's not always right. So therefore, we'll say that this is a false statement. This is false. You should know that not all numbers which is ending with even number of digits will be a square number.